hello, hello. Welcome back to Kottefolket game development log metroidvania game. Yeah, so yesterday, last time, we continued this journey here, and I think what we did was, yeah, we were solving some issues with the FPS being dropped when a bunch of gems were spawned from the chest. So basically 30 gems were spawned, and that was enough to tank the FPS. And I think I found a reason for that, and we fixed it, but now it still kind of, you know, goes down in FPS. Because we're setting FPS to be 100, and it goes down to like 50 whenever we open that chest. And I think that's as far as we got yesterday. So I think the first thing that I want to do is I want to try the profiler again. Now that we have changed kind of how the frame works, we could try the profiler to see if we can find some way of attacking this problem. Now I'm not, yeah, we'll see. I'm not too confident that we'll actually get some super useful information, because it kind of looks like it looked kind of like the same. There was no like bottleneck. It was just that everything took longer, basically. And but yeah, we'll try it once, and we'll take it from there. So what I'll do is I'll start up, go over to the chest and open it, and we'll open the profiler, and we'll see what we can find. Also, yeah, I could just spawn myself over there with the editor, but we don't have a way to enable like profiling option. But I could just add that, to be honest, to the. I mean, I could just add it to the command line when we start the game. But yeah. Oh, what's going on? It's like randomly lagging a little bit. FPS has gone down. I mean, actually, I would expect the FPS to be lower because we're profiling right now. It's so funny when the weird physics happens there. Okay, so here it is. So we open the chest. You can see the FPS drops like significantly, but we can still like move and jump and all that. But now I want to open up the profiler to see what is happening. So, or if we can find some bottleneck somewhere. Actually, I should probably pin this program here, so I don't have to find it every time. Gonna pin that. There we go. All right. Now you don't really see the thing. You actually see two versions of the same thing here. There we go. I'm gonna move this up here. Okay. So this is the profiler. So we'll simply connect. Oh, what happened here? Segfault. Oh, we got the same weird kind of segfault here. Moody camel. We got some C++ stuff happening here. Something went wrong when actually like connecting, I guess, to the collecting thing. Okay, I'll try one more time. And hopefully now it will work. I'll try to be quicker, I guess. Because there's so much data that is being spewed out of this. But if you don't have any server connected, it probably doesn't even do anything. Like, we don't have anything connected right now that actually collects all the zones and stuff. So yeah, I can enable the sound here so you can hear the beautiful sounds. Alright, we'll jump up here. And we'll open this up. I'll start Tracy. Connect. Pause, please. Okay. So it's still collecting here. I'm gonna stop this because I'm gonna do that because otherwise it is prone to crashing. So I will go. I'm not sure. Like, this collection thing is also kind of weird. There's like a weird thing happening over here. Over here, the frame seems to be perfectly fine. They take 10 milliseconds, which is good. That is because we have 100 frames per second, so that is very good. Over here, they take 10 as well. Here they start to take a little bit more, so there we're dipping below the frames. And let's see if we can see whatever is taking up more time, if we can see any bottlenecks here. So the whole frame here takes 12. This takes like 9.37, so it's like it takes up almost all of the real estate of the frame. Can we make like a, can you put like a marker or something so we can go back and compare? Like this frame, can I add annotation? Okay, so I can go to that frame. I want to go back to some of these frames. And this looks more like it, like this takes up half of the frame real estate, which is, I guess it's fine. Usually other things doesn't take that long, so yeah. We have a steady 10 millisecond thing going on here. Also, I want to see like all the way over here. We also get all of these collision detection threadings going on here. Now we probably, maybe what I'll do is I have one thing that I would like to do for oh, did it like remove the other annotation now? Okay, whatever. I'm just gonna see here. So yeah, I think resolve collisions also take like way longer. I think resolve collisions go up. I think I saw that. The search and replace, this takes 500 microseconds. So this is like what takes up most of the time, actually finding intersections. And so we've got like different phases. We have update positions. In the start we have populate, later is like replaced by update positions, which takes shorter amount of time, so it's tiny optimization there. Pre-copying ABBs to make it less cache missy when actually comparing. Here is, and this one is divided, so this is like when we want to search for and report intersections. It spawns a bunch of threads. That's the first stage here. And then we await those threads. That's the second stage. And then the third stage is calling intersection handler for those entities. And I mean, I guess one thing we could do as well is to just call this once with a different structure, perhaps. Because each call does add a tiny bit of stuff. So that might also be something we could do. And then let's see. So what I was thinking is one optimization that we can do is, so right now how it works is that we basically just set, okay, well, we have a bunch of things we can parallelize with searching for intersections. And we just set like number of threads equals 10. Okay, that's how it is now. However, if you only have like 10 entities, it's going to be divided up by the number of threads. So that's going to be like one entity per thread. Let's just imagine this scenario. So that is not a very efficient way of dividing up the things. And if you only have 10 entities, then you probably just don't want to spawn a thread at all. You probably just want to run this directly. So what I'm thinking is changing the algorithm a little bit. So we have a kind of minimum entities per thread. So basically, let's say maybe how many would we do? I mean, that's something we would need to kind of fine tune. But let's just start with 100. We'll start with, so if you have less than 100 entities, we won't actually spawn any threads and do this search in parallel. Maybe we will. Maybe we can fine tune it. We can say like 50 or something. If you have so it's gonna be like 50. So the point is to have like at least like 50 or 100 or something per thread, at least. If we don't have enough entities for that, we're gonna have to calculate how many threads we will have to spawn from that. Okay, so let's start there. Go over to our game engine code here. So let's go over to the quad tree, search and report. Yeah. So here is the code where we do that. So let's see. So number of entries. Now let's add a thing here. So this would be the max I would call this max number of threads, maybe. And then we would have like minimum entries per thread. I'm gonna say 50. Just picking a random number there. So here we have a number of entries. So number of threads is going to be, it's either max number of threads or number of entries over that. So if we have 100 entries and this is 50, this over this is 2, so that will be 2, that will be like 2 threads with 50 each. That makes sense. These are integer types, so I'm gonna say floor, perhaps. What happens then if so if this is 101, this is 50, we're gonna end up with, we should end up with, I mean, we could end up with 2 threads, to be honest, because this is just min entries per thread, and then the last one will just add on whatever entries are left. One second here, I need to answer something. Alright. Okay, so that is the number of threads. Now to divide up. So entries per thread, we kind of already have this. It's gonna be like number of, so instead of doing max number of threads, it's gonna be number of entry or threads. Yeah, this probably won't be a problem anymore since we're doing this. So let's say it's less. Let's say that this is like 10 and this is 50. This would be 0. Which is fine, because if it's 0, then we simply don't spawn any threads. We can just call this directly. We don't need to create a group or anything like that. I don't think we even want to do this. We simply do this part. Now, if number of threads is 0, whoops. Okay, let's actually do this here. So entry values, this will simply be all of them. This will also be just all of them, and I think this also is just all of them. So there we go. So now things will be stored in all intersections. We just go through it. This should be the same, I think, and then we simply return. Okay, so if the number of threads is 0, we do this and return. So over here we're dividing by number of threads, which it cannot be 0 now, so that's also good. And we divide number of entries with number of threads. I'm just trying to figure out what happens if the number of thread entries is 0. I guess everything becomes 0, this becomes 0, nothing happens 0, we return. Yeah, I guess that's fine. We could also add a branch there, but nah. Sorry. Entries per thread is number of entries divided by number of threads. So if this is 101, this is 2, this will be like 50. Yeah, this will be 50 here, div floor. And then the last one, actually, this is just number of threads. No. That's what's happening there. And it's gonna be interesting now, because yeah, the number of entries for this thread could be more. If we're at the last thread, we need to calculate if t is equal to number of threads, then we do, if it's less than number of, actually if it's number of threads minus 1, I guess. If it's less than number of threads minus 1, then this would be entries per thread. Otherwise, we need to calculate, we need to do number of entries minus offset, I believe. That's the, so that's the last one there, yeah. And then you would be number of entries for thread. Is that now? So it's like, as long as we're like the first 3 threads are gonna take entries per thread. But if we're at the last thread, we're gonna take the remaining entries, is the idea here. And then the end would be minimum of number of entries plus offset plus, this should never really be exceeding now. But I guess this is fine as well. We have a little bit of guardrail there. Okay, So now this one is a little bit different, because this is not then gonna be entries per thread. This could be number of entries for thread, for this thread, times the number of entries, and then the offset is gonna be intersections buffer length times c. So this is no longer true. This is the length of the normal one, which actually can be calculated out here. But then the and is also now different. So the length is no longer the case. It's gonna be like number of entries for a thread times the number of entries. So this is the length of the intersections buffer for this thread. This is the length of each one before that. And these should be the same. Okay. Offset should be 0 here. Okay, so we have a special case if we don't need to spawn any threads, then we simply do this. Also, it's like number of threads. I think what we can do, if number of threads is like less than, or let's say it's 1 as well, because then let's say we have, so minimum entries is like 50. Okay, but 50 over 50 is 1, so then we get 1 thread. But there's no point in just spawning 1 thread, then we can just run this directly. So I think that this should be less than or equal to 1. Then we do this, because then we will go in here, even though this is still over 50, it will actually go in there as soon as this gets over 100 or 100 plus. Then this will be equal to 2, which means that now we can spawn 2 threads to share the work. Okay. Let's see if this runs at all. Oops. Yeah, it seems to run. And doesn't seem too performant though. Okay. Let's try with the game now. See if there's any difference. Would be cool to get some music in here for the game. Oh, you don't see what's happening. Sorry about that. I'm not sure why it doesn't show. Okay, now we can. I really feel the lag right now. See, it jumps up to 99 over here. over here it jumps down to 57.6. So it actually got worse. It feels like. I'm gonna go over and spawn the gems to see how it reacts to that. I would like to do a tiny bit of profiling here as well, but I will... do the chest first. It drops here, so let's... All right. Now, not sure why we don't see the main thread now. Okay, the main thread is here. It's a little bit annoying. Like, you have this tool now, but it's like it doesn't work properly. But okay, let's see here if we can see anything different. Okay, we can see here actually that we are not actually spawning any threads. Maybe we should lower the... And that also makes it interesting because we... yeah, that actually makes it so that spawning threads actually takes less time, which is really cool. However, we can see here that there's a lot of intersection going on here. This one takes 1,000 microseconds. So how many entities do we have actually? In that scene. Whoops. Let's see. Let's go ahead and I guess lower this a little bit. I was sure that we had more than 50. Maybe it's because we're just below or something. I'm gonna say 10 then. Pick something that might work a little bit better. I don't know if this is more performant or not on this specific example here. Now I actually don't want to connect this one yet. because it usually crashes when it's like trying to collect more things. All right. Oh, okay. So initial test is better, way better, but it does go down a little bit as we move along here. I mean, I could just have a chest spawn in the... Man, why is it like... sometimes it just stops. Okay. Moment of truth here. Well, moment of truth. It's better, but it's still... I think it's better anyway. Alright, let's do some profiling here. So, pause, please. Collect a bunch of stuff. And I think... No, don't crash, please. God damn it. Oh my god, what is happening here? Okay, game crashed. And Tracy crashed, okay. And basically everything crashed. Great. Man. Okay, let's do this. Let's open up the editor instead. Failure. What? Oh. The problem here is that we are using a different version of Zig here. Run a command with the given Zig version. Okay. Wait. Hang on, I need to restart OBS chat here. There we go. Run a command with a given Zig version. How do you give the Zig version? Usage. Okay, I thought that you could maybe change the version. Hey, I can actually replace this with Runic now. Alright, basically all of these are the same. I was thinking like I mean, we could also do couldn't we do like this? Oh, it needs to be on the same, okay. Oh yeah, .exe doesn't work. Gosh darn it. There we go. In this case, I don't think Runic is better, but whatever. But the thing is, I think that what we want to do is we probably like it will probably change once we've got like error handling in place, like Zig-like error handling. So if we run this, we get the same issue here. What the hell? Why isn't it not showing up? Okay, anyway. Oh yeah, I also wanna okay. But what I wanted to do here is I wanted to say Zig version is equal to Zig version, and then we want to ZVM use 15.1, and then after this would be insane actually, because we can defer. If like when we have defer, we can actually, you can actually do this. So you can do like defer ZVM use like use zig version. So you go back to whatever version we had, right? And that would happen like at any point we exit out, this would happen before. So that's really cool. If we could get that to work. I mean, I might just put AI on it, to be honest. But yeah, anyway. But we want to do this at some point. I'm gonna just make a function for it. So we'll just do like restore. And this is simply gonna be use zig version, and then instead of exit 1, well, actually, I wonder if we put exit 1 in here, will it exit as well? Or is it gonna exit? Is it just this part that's gonna exit? I don't think this will exit the whole thing. I don't remember now. But essentially we just call restore now instead. Oh, except you don't do that. Actually, instead of doing all this, instead of having if like this, we can just do or. We can just do this right now. Actually, there we go. That might actually also work better with the standard out. And if we do get over here, we also want to restore. Actually, we don't want to restore. Well, we do want to restore, but we don't want to exit. Let's just do this. Oh man. What the hell, man? Okay, that works. So let's do that. And then over here, we actually do restore as well. There we go. So now if we run this, it's gonna switch. Why didn't it switch back? Wait, index out of bounds. Runic. Oh, because Runic has a bug, probably. God damn it. Okay, anyway. It's, yeah, that's good. I can put that on the thing. Let's do it in here instead. I just don't like this thing. Okay. Zig version equals zig version and zvm u015.1 and actually is this JQ? No. Or I mean a JSON working thing, and it's not. But you can do like version Yeah, but whatever. I'm gonna use this, and then in the end we want to restore. Can you do like a one-liner? No? Okay. I mean, you can do the same thing here, I think. Or restore. Like, I'm not sure if this is gonna get grouped here. How do you group? Because adding parentheses will like make it into a subshell. What the hell, man? Okay, it did win. It did go back now. And of course we got some memory leaks. Okay, there we go. Anyway, now we got that little thing out of the way. Let us go. What the hell did I want to do actually? I think I just want to like, yeah, actually we could just start from here. Or not. Wait, why did we start there? That doesn't make sense. It's gonna be interesting now to go back to like this old code and see how many places. It's always like that, like when you've learned a new language and you look at old projects and see, oh man, I did it like that back then, and you found like a better way to do it. See. play command. Okay, so we could probably see the whole thing with that. What the hell's happening here? We've got this thing. Wait. Wait, why does this not work? I see. So when we're in this project, it's kind of annoying actually. When we're in this project, we have to change the whole version out. And of course now ZLS doesn't exist. Because for this version we actually use another one. Yeah, because this I didn't have good experience with this this version here, so but I guess we'll try it. Okay, there we go. Okay, so what the hell is going on here? We have a play command. Alright, that's a string Z. Okay, that is something that you can actually define in the editor, right? So let me look at that. And where did we have that? Project options. Yes. Yeah, this is the Windows path here into WSL. And then we have the actual name of the thing. -- scene. All right. Okay. So let's see here. This should show this is the game log here. Also seems to have issues loading the save file. Running games with arguments. All right. Okay. Hello, AQ39, what's up? Welcome. How's it going? Welcome to our game dev log stream here. Interesting. So it doesn't seem like the thing works anymore. I guess we can try another one. Let's try this one. No. Oh, this one seems to crash. No, it just took a long time for some reason. Okay. So it seems to start me like what I'm trying to do. I'm not sure if you can see this right now because the editor is in the way. Actually, let me move this. Wait. Why is it like this? Okay. Yeah. So I'm loading it up. I'm expecting to get to start here, but it starts me at the beginning instead. Reminds you of Lemmings. Yeah, this is the editor that you're seeing right here. And then the actual game is this here. So this is the actual game here. Now the sound stopped working. Wait, no, it's just my headphones. What the hell is it called? Headset. Why isn't it not connecting? Okay, anyway. Okay, so hang on a second here. I need to fix my sound here. One second. It's like my headset was connected to the computer, but then all of a sudden it stopped. It's talking about it. It has like a voice. It's like PC connected, but now it says like phone connected or not. Like no phone is connected. I'll just remove it and re-add it here. Hopefully this doesn't mess up anything. Yeah, no problem. Do you like metroidvanias? Bluetooth is turned off. What? Okay, my Windows is acting up here. You know what? Whatever. I don't really need those headphones anyway. As long as the sound goes through, it's fine. Alright. So, I need to figure out why it's not loading the thing. The one thing that I could see is that we are not loading the save file properly for some reason. So let's go and look at that. Maybe I disabled it by default, but we'll see. We have the load here. So this is called enable temp file. Right. So if we're not awesome, we have this. And then we load that. We should have like a save file. Yeah. Actually, let me look at this file here. It does have content there, so. Yeah, because the reason why I want to go in here, it has obviously worked before, but now we've upgraded to Zig 0.16, so there might be something weird going on with the IO stuff. The IO is new thing here. I am currently saving this in my game struct. And it should be a stable pointer because this is the IO we get from main, so that should be good to use. And you are a save thing. And if we have that enabled, which we should have, we are loading that. And then it says could not load save file. So if we just start up the game. Oh. Right, I have to change the version. But we start up the game. And, well, I can already see that we're not loading the file because we start with nothing here, so and the logs should say something like could not load save file. Yeah, end of stream. Okay. And then we just return, so why couldn't we load it is the question. End of stream. Yeah, so this was also changed. Before, I used a function on the reader itself. This is the file reader. And there was like read functions on here, but they were all deprecated. And so you have to go through the interface instead. And here we have a bunch of read stuff as well. But for some reason now it says that end of stream. Like, is it because read slice all? Okay, so read slice all. What is the documentation for that one? Because it could be that we're passing in a too large of a buffer or something, and then we get an error. Okay, if the buffer cannot be filled completely, end of stream is returned. So end of stream is actually, we could just, okay, so what we do is we handle end of stream and just say it's fine. What do we get though? We don't really, well, we do get a slice out. But if it's end of stream, we don't actually get a slice though. I wish there was like a setting for that. Maybe we need to do use another. The game is not open source right now, but it's the editor is open source, and the game engine that I'm using is open source. The game engine I've written myself is basically a very hacky engine, but it's and it's also like using an ECS library. It's using Raylib. You can find those on my GitHub. And so yeah, if you want to check it out, there's some links in the description if you want to check out some of those. But the game itself is not open source right now. I might make it open source, but I haven't decided on that. But I do have another game that's open source, but it's a little bit unmaintained. If you're interested in looking at, like, it's called Busy Taxi. If you're interested in looking at an implementation of the game engine, but it's like, it's not up to date, so unfortunately. Alloc remaining. Maybe that's one what we want to do. Transfer all bytes from the conversation to the end up to limit, returning them as caller own slice. If limit would exceed stream to longest return. Okay, this seems more like what we want to do. Because if it's larger than 4 megabytes, I don't know. That's just the limit right now. So there you go. If we reach, yeah, I'm gonna add a to-do here. Do we need to handle 4 megabyte plus? Is it this or this? This is like the old notation with capital, but now there's like bytes and whatever the other thing was. 4 megabytes plus cases if there's going to be one. Alright, well, if there's going to be one, probably want to handle it, so. And now this is a limit, so you simply do this. So there we go. Now we alloc remaining instead. That has the behavior that we want. Now when we load, we should see that we have some gems at least, maybe. No? Okay, but if we take a quest here, we have this quest now, and we exit. We go back in, and we still have the quest. So it does work now. Cool. However, I'm not sure if the scene loading works. That might actually have the same issue, to be honest. But let's open up the editor. And also, yeah, actually, AQ39, you can actually play this online. It's up at... Wait, where the hell did my browser go? Apparently it crashed on me for some reason. Okay. Interesting. I didn't notice that. 1 second here. Let me get to the thing. Let's see. GitHub. No, not GitHub. Lumors.com. Yeah. Oops. Oh, it's down. Okay. You used to be able to play it, but now it's down. So let me see if I can just fix that real quick, actually. If I remember how I did that. Yeah, I think I just have to run this thing. Oh no. Uno momento. I'll just see if I can make this run here real quick, and because I should just be able to start the server here. It should work. Wait, did it start by itself now? Okay. So you can go here to play it in the browser, but it's an old version. But it is playable, and yeah, it does work. However, I actually need to. So one second. I just need to. Spawn up. The thing. And there we go. So now it should be like it should be going online here in a second. Yeah, it's gonna be available in a second here. Actually, I'll just connect to see when it comes online here. In the meantime, I want to see if... Okay, so that still doesn't work. But the saving should work here, yeah. Okay, now it should be available. No? Maybe not? Now. Okay, now you can try. I had to like restart the server since the computer that it was on was restarted, and I haven't set up like a startup script to start all the servers and stuff. But it usually doesn't restart itself though. But yeah, now it should work. And there's some, if you scroll down, there's some like instructions. All right. Okay, so I want to see why we are not running this properly. Also, I want to see, like, is it building the Zig project? I don't think it's doing it. We have to build. Yeah, it's not relying on building the game first. We have to do it ourselves. Yes, I can play it. Okay, good. I'll just BRB 1 second here. right. Yes, good. Does it work fine for you, AQ39, sorry. I was thinking about AK-47. Okay, so the loading works. Loading a scene doesn't seem to work. Okay, yeah. So the arguments also changed, so we might have to do something here. This takes like the arguments. I mean, we could log out. Oops. The arguments. Wait, no. We actually have to do it like this. Because you need to specify a formatter. I'm not sure if you can. It would be cool if you could specify like a formatter for an array. Because I think sometimes it like takes the thing, or a slice. It takes like the formatting specifier and applies it. Like if it's a vector, you can apply like number formatting stuff, and it would apply to the components of the vector. But for slices, it's like S is saying, well, I guess we could try as well. We could try to do just this here. I'm not sure if this is gonna work. It's gonna complain here. Expected this, found that. Okay, yeah. So that did not work. So like S is specifying how is the slice going to be interpreted. It's going to be interpreted as a string with ASCII characters, so that's how it's gonna be displayed. So, but this is not a string, it's a list of strings or a slice of strings, so we have to do this. Anyway, let's see. Well, let's just run it and see what it says. So, somewhere running game with args. Wait, where is this at? Oh, I see. So we kind of already did that. I just wanted to see everything here, but I guess that's already done. Yes, it worked. Okay, cool. Thank you for trying it out. So that is that. Maybe it's like out of order or something. I don't know. That would be kind of strange though. Q is for yeah. So Q is so what you're seeing here is like a debug view, or like it's a visualization for the collision detection algorithm. It's a quad tree algorithm. So what you're seeing is essentially the quadrants being shown here. So when I'm over here, we see a red line forming here. It's actually part of a rectangle that is like created here when we pass this boundary. Yeah, and then you have C. C enables collision boxes, basically. Also, climbing ladders currently does not work, although it might work in your version, because this is a different version here. Alright, I want to see the logs here now. So running with args. What the hell? Wait. Why is it not showing for I equals 1? It shows only if here's like 0, 2. Where's 1? Oh. Wait. This is not correct. There we go. Okay. So in the process of doing this, I had to change this from a for loop to a while loop and do some weird things because I needed to actually, yeah, sometimes we want to skip. So in these cases, we actually do want to skip like this. There we go. Now this is a super bad way of doing this because if someone puts like dash dash scene and doesn't end like follow with the scene or follow with any arguments after, this is just gonna crash here. Or it's not gonna crash. Wait. No, it's. I guess it's just gonna. Actually, it's just gonna abort. But there's no like checking if a scene actually is a scene or, well, not here anyway. Maybe we do it over here. Okay, anyway, that is probably the reason why it didn't work. So let's try this again. And we will try this. No, it still doesn't work. Okay. Wait, did I build the game properly? I don't think I might have not built it, so I'm gonna build it here first. Alright, and then we'll go back here. There we go. Now we can actually... I want to see if I can get my controller to work as well. Although the Bluetooth was like super weird before. Couldn't connect. Okay, Windows is super weird. Like now when I go to Bluetooth, it doesn't even show like turn on Bluetooth. Okay, I had to like plug the Bluetooth adapter. I had to unplug it and plug it back in. Because it would be nice to get it working. Okay. Flashing. Yeah. This controller has been like a lot of troubles with, because it's like it's really meant to be used with like a Nintendo Switch, and it has worked like connecting to the PC, but a lot of times it also doesn't work. So it like you can connect it with a cable, but when you do that, it doesn't actually get you the correct the buttons are like triggered. It's like the wrong like driver or something. I don't know. It doesn't work. It just only works if you connect it through Bluetooth. But then it's like it doesn't actually connect sometimes. It's so much easier to play with the controller, and I get a more better feel for how it's supposed to feel like. All right, okay. It doesn't really work. Maybe I'll just order some other controller. This one does not work. Anyway, now if we go here, we can see that we have like 100 FPS. Now we're not running the profiler, so that might be the case. But what happens if we open this? We actually we actually do go down to 50 FPS, because there's like 30 things spawning here, and they all spawn in the same place, which means they are like brute force checked against each other, or at least a lot of things are brute force checked against them. And if I collect a few things, I go back to 100 FPS. So it's still kind of like a mystery here. Now what I would like to do is I would like to add a thing to the command line. Actually, I could just add it straight up. No, wait. Actually, it's the build part. So if we build with ztracy in, then we could just run it with profiling. Yeah. So if I start now, it should already be profiling here. Oh, and okay. The chest did not respawn. So let's... Yeah, so I have to actually remove the save file. And now we load. Now the chest is not opened. We open the chest, we get some lag. We open the profiler, we connect, we pause immediately. Wait for it to collect everything. And stop. I'm gonna exit. And I will show the profiler here. All right, so okay, now we actually have this kind of working here. So I'm not sure what's going on over here. I think this is where we pause and something is happening, weird is happening there. But then after that, we should get a bunch of these, a bunch of good data here. So we can see that each frame here takes 25 milliseconds. Wow, that's a lot more than I expected. Over here, we can see that we're at 10. So this actually holds 100 milliseconds. Wait, is this collecting from the start? I thought it just collected from when you pressed connect. I'm confused. Maybe we should start collecting screenshots. Cause yeah. And then over here, you can also see that more threads spawned in, I guess. Perhaps. So over here, the frames, yeah, it takes like 3 times longer. 30 milliseconds. So that would be more like 30 FPS. A little bit more than 30 FPS. Physics update now takes 20 milliseconds. Not sure what's going on over here. This should also be like take longer, I guess. The rest of the things, but the physics update takes a really long time. And we can see also that the resolve collisions now take way longer, actually. So that is interesting. I was thinking of an optimization actually regarding this, because you have a bunch of gems, right? Now these gems, they don't really have their own, like they don't really have like their own acceleration. So once they are at rest, they don't really need any they don't really need any like physics you know, happening to them. It's essentially, we have like too advanced of a collision system for this very simple game, really. You ventured all the way to the left until you reached a lake where you can walk on its surface. Huh. I don't actually remember that. Hang on. To the left. Oh yeah, and you press space, it of course. Oh my god, this is so stupid. Okay. So does this happen for you as well? Like you press space, it actually moves down like that. I think you could probably disable that. What the hell? Yeah, there are some issues with the web page I need to fix. Also, I would like update the version at some point. Yeah, this is a really old version here. Yeah, yeah. So the version that you're seeing right now is actually like an old version here that I'm playing on. Oops. In the browser. Oh, we actually got all the way over here. Where's that lake that you talked about? Because from here you just go up. And then down here, you can only move down, I believe. Yeah. Anyway, yeah, it is also less laggy because what I did was I optimized the collision system a little bit. So now we're actually using multi-threading now, and we can see here. Whoops. We can see here that we're spawning a bunch of threads. Now this is way more optimized now. We're spawning 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 threads. So that's maximum. The maximum amount of threads actually. And then we wait for that, takes like almost a millisecond. And then this part also takes a while here. I think maybe we could optimize this part. Maybe, because there's a lot of function calls here. Although to be honest, some of the function calls doesn't take that long, but each function call is probably taking more time than because there's so many function calls there. I think it's better if we just pass the whole thing in there, and then the intersection handler will process the whole thing at once instead of doing, because it was like meant to process piece by piece, but now we're doing things a little bit differently. So let's try that. Yeah, so now we have like threads, we have maximum number of threads, we have min entries per thread. Actually, we could probably increase this maybe, I don't know. This would be also limited by the IO interface as well. So I mean, it doesn't really hurt for us to, I guess, increase this maybe. 20. I mean, we could just, let's just increase it to 20. And I will rebuild. I will build it without profiling first. And let's see now. Man, why are these windows not showing up? It's actually kind of annoying. Okay. And then I press play. And we open up. No, it still goes down to about the same. But it did, I think it did increase a little bit once we collected the things. Okay, that was one thing that we could like modify. We can also tweak this part, like how many entries per thread. I could increase this to 15 or something. We could try, tweaking a little bit. We probably want to, like, if we really want to do this for real, we probably want to set up a bunch of scenarios and check, like, optimize so that we can see that each case is not lagging. Sorry, I need to remove save file. Yeah, there's not much difference here actually. But there is a big improvement when you collect like a tiny amount of them. But it seems to be like it goes down to 50 and then it kind of hovers there. Okay. So that I'm gonna leave this here for now. what I'm gonna try and do is I'm gonna try and deal with this, the intersection handler callback, whose job is to kind of compile the result into another format, basically. This is, so there's no reason why this should take this long here. It essentially takes up almost half of this time, and this time is like a fifth of the entire frame real estate. So that is kind of unacceptable, to be honest. So let's see if we can fix that. So the way it's done now is that we store everything in this list here. This list is essentially it's a slice of slices. So it's kind of like a map from entities to intersections. A map from entities to a list of intersections, where the key is, well, we get the key like this here. So maybe what we could do is, like, we want to pass in this one instead. However, we kind of lose the key information. How do we pass that along? I mean, I guess we could just pass this to say, hey, these are the keys that you need to look into, because this is quite large. Like, there's a lot of iterations in here, and then we call this every time. So we get rid of this barrier, the call barrier, if we just call it once, we pass in this, and this is going to happen. So this intersection handler, I'm going to change the signature here to be instead entry keys is a slice of case. What the hell? Oh yeah, and then we receive a slice of intersection case. Yeah, and that's actually the only change we need to do. I think we do need to update that one as well. And this one. And that one. Okay, there we go. Now we need to go to here. And I'm gonna rename this, or I'm gonna make another version of this that just takes all. Get entity keys, we get intersections. There we go. Let's just see. I mean, it's not that big of a change. We can just see, okay, does this actually give us anything? Because my theory is that the function calls themselves are large enough. Like the time it takes to call and return and all that is large enough to actually become an issue. That's the hypothesis. I guess we'll see if it actually is like that, but since there's so many of them, like calling a function, it doesn't take that long, you know, just the overhead of calling a function. But when there's so many in such a small space, it seems to add up. So everything adds up if you scale it up, you know. So okay, so we have the allocator, we got the, well, this should happen for each entity. So at this stage we're gonna go through, I guess we could just go through all the entity keys, and we get a range matching, an index matching there. This would be the entity, and then actually, you know what, we can do the zig thing here where we take both of these, and there we go. Now we have both the intersections and the entity. We don't have to mess around with any indexes actually. Okay, and there we go. There's our change. There's not much change there. Now we need to say all here instead. Cool. And right, so here instead of calling this like this, we just wanna call this with entry values, I think. Yeah, and then this would be all intersections. There we go. Okay, fine. It's actually const. Now you can alias this type, so, but I didn't think I would have to change it that much, but there we go. And then we have to go back here, and you need to also mark this as const. There we go. Anything else? There is something here, yes. The other place where we do call this. Oops. Same thing here, enter values, and all intersections. There we go. So now we got rid of all those calls. Let's go back here, and we will save this again. See if that makes any difference at all for this eyeball test here. There we go. So let's open up the editor, start a scene, open this up. Okay, so about the same, I would say. Yeah. It would be interesting though to see the actual profiling of it. So I'm going to build with profiling. And this trace took like, so this took 1.7. So let's say this took like 0.7 milliseconds or something like that. I mean, it's hard to compare strictly like that. It seems to be pretty consistent here though. And here it took even longer. And that seems to be an anomaly. Around 1.7, 1.4. Yeah, but maybe we look at like, it's almost like half. It's like almost half. So we can look at that. Okay, it's built. We want to remove the save file. We want to open the editor. Run the game. I'm gonna open the chest straight away. I'm gonna go here. We're gonna do reconnect. Pause. And it's collecting. Okay. I'm gonna stop it there so we don't, like, we might get some bad data by stopping, but I just don't wanna have it get crash and have to redo this. So it doesn't seem to have actually gained much, to be honest. It looks almost the same here. Interesting. Yeah, I mean, okay, fine. So I mean, yeah, there might be other overhead than in here that were like this. Like, I'm not sure why this takes so long, to be honest. So this is that function here. We could zone this out to see what each different part, how long each part takes. We have a bunch of branching in here. We have static checks, solid checks. I wonder if we could just transform this into a arithmetic based just to improve this here. I don't know. Like, if we could get rid of all the branching, maybe how much faster would this go? We have like 1, 2, 3, 4 branches going on here. Or even 5. And also, we're doing this. This has a zone. Why is that zone not being reported? It should show up beneath here. Can I? How can I see? No, it doesn't. I mean, yeah, it doesn't seem to call anything. Huh. That is strange. I mean, that must mean that it doesn't get here because this is a zone in itself. Oh, yeah, okay. I see. This is important. Like, basically, okay. So how this collision system is built up is basically every body, like every entity, has an axis aligned boundary box, which is an AABB, is a short for that. And it's like the collision system was built from the idea that you would be able to have other, like, you wouldn't only have rectangle hitboxes, let's say. You could have any shape, really. And the check that's done here is basically checking, like, okay, are both of the bodies minimal? That means that are these AABBs, do they equal to the hitbox? Because if you let's say you have a body, an entity that is a circle, let's say, then what we do is we draw a, because it's easier to check AABBs than to check circles or rotated rectangles or anything like that. So AABBs are created that will like cover the original body. So let's say the original circle, and then isMinimal will be set to false because it's not equal to the hitbox anymore, or it's not equal to the circle. So that means that if isMinimal is set to false, that means we have to do additional checks to see if we actually have a collision, and that is done over down here. So check collision is like an interface function here, which checks based on the type or based on the body shape. It will actually do a more detailed check to check against, like, let's say you have an AABB against a circle, or you have a circle against another circle, or you have, whatever shape you want to check against something else. But we don't ever get down here because all of our entities are minimal. That means like all of our bodies are basically, AABBs. There's no rotation going on in the game that changes the hitbox. The hitboxes are always AABBs, so it's always going to be minimal. Just to explain what's going on there, and for me also to understand, revisit this part here, because I was like, why aren't we going down here? But yeah, that's why all bodies are minimal. So we simply just add a new collision thing here. I'm almost contemplating to kind of add a special case where we can just set a flag to say that, or even a compiler flag that basically says that, hey, we're never gonna have anything that is not a minimal AABB. So you can use a more optimal like algorithm to do this. So yeah, that is one thing. Also, we're checking these things. So essentially what's happening is basically we're going through all of these and then all of the intersections that they get. We grab some things. These operations are really all ones. I think these are very fast, just array accesses here. I mean, they could be cache misses, to be fair, but yeah. But then we have a bunch of branching, and we have another branch, and we have this thing here. And that's it. That's all that's happening in here, and it takes that long. I'm not sure why it takes that long. Maybe it's because there's so many collisions happening. I'm not sure. Maybe one thing we could do is, since we ignore static versus static, solid versus static anyway, maybe we could move that into the quadri logic instead, to say that, hey, are these two bodies even, should they even be like considered to be colliding with each other anyway? So my other thought with that is that, I mean, we're doing the comparison anyway, so it would be faster to move this into the thing. Like maybe we have a function, like a filter function. And in that case, we don't add it to the list in the first place. I don't know why this takes so long here. We could zone everything out so that we can see what is taking so long, though. Is it these accesses? Is it this part? It seems silly to zone this part though, but I guess we could. Body zone. So we get the body. And zone will end there. And this part is looping through intersection. Intersection zone. Okay. What else? We get the other one. We do some branching. Do we really want to zone this? I mean, I guess since we're zoning this up here. Let's call this like other. Get other. Okay, and then this is the branching part, so let's just add branching. And I guess we have to duplicate here a little bit, because I don't want to defer, because then it happens like, I mean, I guess we could actually create, I mean, yeah, we could create a scope actually here. I think that's how you can do it. And then this simply appends into here with an allocator. Yeah, I mean, sure. Like, I know that this is gonna be cold, so let's just defer here. There we go. Okay, we've zoned it out. Let's see if we can find out what is going on. It seems strange though. It seems like we're doing super micro optimizations here. And but yeah, I am interested in why it takes so long. So let's just see. First of all, it would be interesting to see how much this will slow things down now, like the actual profiling part of this. Yeah, it slows it down a little bit more now. So let's reconnect here. Pause, please. And we'll stop at some point here. Please stop. There we go. So let's go over here and see. Okay, we have a lot of things happening in here. Let's zoom in to see. It's just that there's so many things, I guess. Like, how much is this? 1490. 1.76 milliseconds. Like, that's so much. That's so much for just 1490 like iterations or whatever. Wow. Okay, that has to be a cache miss here. 1.77. So that's, I mean, that's fair. It's like the first one. And then this takes so long. And then this is another probably cache miss. The branching doesn't take that long, I guess. Append 40. Okay. What the hell? What is happening over here that is taking so long? There's something like between here that takes long. So, is it just setting up the zones? Because the only thing that's happening is that we create this zone. That's the only thing that's happening here. Okay, maybe we're at that scale. We're at the scale where setting up a zone takes like a microsecond. It's like a microsecond is that long, but when you have 1500 of them, that becomes 1.7 milliseconds. I think the problem might be fundamentally how the quad tree is built up and how the like intersections are done there, possibly. My thought is there that right now, I mean, for example, each ground shouldn't like each ground tile or ground entity, because we have like a lot of ground entities in there, they shouldn't like intersect with other ground entities. Like, that is one thing. We don't have that check here. We don't have a check for that. That's what I was talking about, the filter function. Maybe we'll just implement that. It's like, if we can filter this out before we even get here, we would spend a lot less time in here, because we're doing this check anyway. So let me move this to a function that is called a, I guess, body filter, intersection filter, body A. The problem though is getting the things. This will probably be like a bunch of cache misses, but GCEIB. Alright, thank you, AQ39. Have a nice day. Hopefully I'll see you later. I'm streaming on and off. There's no schedule really, but around this time basically, almost every day, except on weekends. But yeah, thanks for the follow on GitHub, and yeah, have a good one. Actually, these are entities. The bad thing here is we actually need to grab this information We could, I guess we could cache it. Nah. So let's go. Body A is gonna be. Oh, and then we need a context. Get. Oh no, rigid body. Body A, body B, okay. So that's the filter. Now, we need to pass in the filter here. Also need to add a filter function here. The context actually, yeah, that's the same context. Okay, cool. And then we have like entity A, entity B. So it's just gonna be KK. KK. And then we have to pass this here. I guess you would like the filter. These are K's. If we need the context as well. So the order doesn't matter. Wait. No, this is not correct. We actually need to pass it along downstream here. Yeah, we need to pass it like to everything in here. Unless we have it like in our context or something, like in our in self maybe. That you can set the filter that we don't need to pass it. It's just gonna be so many changes. Okay, whatever, let's just add it here. So essentially we check for intersection. However, we also want to check the filter, but now we need the context as well. Oh man. The problem here is also for cache misses, because before these ABBs are fairly resistant to cache misses, because we're going through the ABBs over and over again, and they are very close in memory because we copied them before. We kind of optimize that, but this part is not. So I'm not even sure how much time we'll be saving on this one, to be honest. If it's worth even doing this. How? But maybe, okay. I mean, there's probably a better way to do it anyway, like passing a function which gets more information. It's basically the worst case, like it's basically the worst way to do it. A better way to do it is setting some kind of, I don't know, flag, bitmap or something that we cache the same way we cache, the same way we cache these. We cache like a flag, and then we compare those the same way we compare intersections to see if with some kind of, you know, operation to see that, okay, well, are you able to intersect? Are you able to do this? Yeah, that's probably way better. The question is, how would that look? I mean, we only have two things. We have static and solid. What you could do, and essentially what's going on here is essentially we're checking for the static. Is like if both are static, we don't really need to do anything. So that, what would that be equivalent? Let's say we have a map. It's solid and static, let's say. And then B map is also solid and static. So the first one would be if it's static, the second one it would be if it's solid. And then it's like, what is the operation? Maybe we need to do several operations. But essentially, we just want to check if either of those operations are true, or have like a value, I guess, greater than 1 or whatever, however we want to call it. So the result. So this would be AND, because it's like, if you look at the truth table, basically it's only true if both are 1, which is the case here, right? So if this is more than 1, then we should be fine. Okay, and then we have like AND again. No, we don't. I think we have like OR. No, because now this also is true for if both are solid as well. I guess we could filter it first. Yeah, actually, we could filter the whole thing by solid. Hello, Mutasimus. What's up? What's up? And then this. No, actually, this is solid. This is static. So, if both are static, that means this should be now positive. Okay, and then we OR by, let's see, because if so this is an OR, like either this could be true or this could be true, then we continue, right? So this operation is like both of these. And now we're gonna check if both are not, no, if either is not solid. I had to come see for myself. Someone's writing code by hand. Yeah, exactly. It's all AI now, right? I mean, I've been using AI extensively to keep up with the times, but that doesn't mean that it's still fun to write by hand, and it's also necessary sometimes. Yeah, welcome, Joshua. What's up? What's up? Let's see. We're doing some bit manipulations here. I'm gonna change the order here. It makes more sense to me. Doesn't really matter that much, but whatever. And then I want to group this to not get some weird ordering happening. So that is the static. Or, okay, let's go through this again. So static and A map, B map. This is essentially like these two ANDed, but we're only interested in the static part, so we're filtering out only this part here. So that should be good. Then we're doing the same thing with solid, except these two is like there's an OR, but then it should be like not. So do we negate them first and then do an OR? Or is it, can we do better? I should add support for loading alpha version worlds for my game. What, do you already considering adding backwards compatibility? Or like your own alpha worlds? Is this the same thing now? This should be negated here, right? Negated, so this should be like if it's not solid, then this should be true, right? And then OR this, and then that's the result, and then we simply check if this is more than 1 or more than 0. I'm not sure about the precedence here, so no, I mean, it doesn't make sense if this was evaluated first and then we bitmap and a boolean. That doesn't make sense. Okay, so is there a better way to do this? Like, what if we OR first? No, wait, what's the inverse of that operation? If either is 0, that's what we want to try and figure out. If either is 0, what about X or no? Because that would XOR doesn't differentiate like if both are true or both are false. It just XOR is just, it's a way to detect if they are different somehow. But this is different. This is essentially, wait, should we just do an and then negate that? Yeah, I think so. That saves us one operation, maybe. So and will be true only if both are 1. And only if both are 1, we don't go in here, right? So and then negate should give us the answer, because if any of them are 0, then this becomes 0, and then we just negate that. Yeah. So we negate, and then we do an and like this. Cool. Watch me implement this, and then when you start the simulation, it's like everything is moving through everything else and nothing works, basically. Alright, I'll just refill my coffee, be right back. How do I remove you? There we go. Cool. All right. Yeah, so basically the idea is, because right now we're kind of getting these through getting these bodies and stuff. Now, I mean, sure, these could change per frame, but they usually don't. But they can, actually. I just remembered we are doing that in the case of the boss, I believe. The boss is static, I think. Oh yeah, maybe we are not actually changing that. I don't remember. Oh, the players changed. Right. When we climbed ladders, animation and the death animation. Right. So, well, bottom line is we should support checking if this has changed, perhaps. Now the question is, how do we store this? And also this operation, like how, like, is this just gonna be a part of the quad tree? I guess that would be the quickest way of doing this. I wonder if you could probably create a language in ComTime that you can actually, like, you can make this kind of operation as a ComTime like language that is then creating this operation based on your specifics in the game. Maybe? But yeah, let's see if this actually does any difference for now. I'm gonna remove this. I mean, what we could do is basically, if we remove this, and essentially we just remove everything here. Now we try, and we see if then actually, if this even does anything. We could do that. That's a quick check to see if this increases FPS. Inline functions. Yeah, the thing is about inline is that the Zig gods have told us that inlining, like, you can mark things as inline, but there's no guarantee to what's gonna happen. So it's like, I just stay away from it. What the hell? Okay. Okay, so we can't really compare this, I guess, because I get a lot more collisions this way. Right. Actually, this wouldn't do any difference at all, actually, because... Oh man, I'm so stupid. Because this is not the place where this should happen. Okay, well, let's go to quad 3. What I want to do is I want to add a thing here, collision or intersection filter. So we'll add entity maps. Essentially gonna be a list of U2s. Actually, we don't really know how large this can be. This is probably better if this is an array list. Man, I really hate the allow 0, because it's like when you have an allocator, this goes up to the top. For some reason, it doesn't even, it's not even alphabetically or above. I think it's just because it's a keyword. So it's like, I wanna type allocator. So I type all. I usually just press this to get the first one, because I just assume it's going to be allocated. Even though I've done this like 1,000 million times, I still do this. I still like autocomplete to allow 0, even though I know that's going to be the case if I do this. What if I add a T. Okay, so all T, that's the allocator. Cool. It's a little bit annoying here, but there we go. Anyway, so here, so we have static solid is gonna be those filters. Right, and then this is the operation. So filter operation. I mean, yeah, you can't do like inline function, but it's like, as I said, it's not really guaranteed what's gonna happen here. And they essentially just tell you to not do this, basically, because it's like, we don't really know what's gonna happen, but it's so stupid. I wish that we could kind of have this, because it's like very convenient to be able to just do this here. Yeah, that actually works. It's kind of easy also to type alt. Okay, it's just that my brain always thinks like, type the beginning of the thing, and then since there's nothing else in the vicinity that has the same name, my brain is like, this is like how my brain has been trained. But yeah, I guess I have to like rewire my brain a little bit. It's 3 letters again. Yeah, that's true. Okay, I just have to like train my brain into this new pattern. Filter. Okay, so another idea. What if we just make a huge map, like a vectorized operation? Now there's no dynamic vectors though, but my physics engine actually has like kind of like a dynamic vector. But how it works is that you have, it's a vector array list. So how this, now this is tuned to like the physics simulation. But it's essentially just it's like a dynamic list of vectors, and each vector has this many elements. Like for this one specifically, this, I mean, we could also change this out so that you can set the number of yourself. But essentially, it's just, you have vectors, and then you have the elements within the vectors. And accessor, yeah, this is just a way to kind of say, hey, I want to access these things. And we have like element. Oh yeah, so essentially you have an index into the whole list. You can turn that into and this kind of vector index and element index based on this, so that's fine. So we could probably use this thing to like vectorize that operation actually. Like if this was a vector instead, a vector list, we can, I think we can still use the same operations. It's just that you don't get one answer back, you get like a vector back. And then I think we store that, we could store the result in a another vector list. Actually, we could just use the same vector list because it's kind of optimized to the generically how many elements you want to have in the thing. However, the elements are always F32s, I believe here. Yeah, the vector type is not correct. Is this used anywhere else? Yeah, but only here. So actually we could probably get away with, let's change this to a type T. Okay, well, I'll name this E. I wonder how that works. Like, you have a vector of U2, like, how does Zig optimize that? Init with capacity, right? Init capacity. Actually, this could just be empty though. Wait, we store the allocator as well? Where do we actually use that? The initialize and short capacity. Okay, so that's actually, yeah, let's just remove that. This could be fine though. Comtime type implies a runtime type. No, it's a comtime type. There's no, you can't create types at run. There are no types at runtime, basically. Everything that has to do with types is done in comtime. Does the compiler just enforce type params to be comtime? Yeah, that's kind of strange. It's just like comtime is like if something is a type, it has to be comtime. So it's like if you omit comtime, I think there's just going to be some kind of compiler error somewhere that says that, hey, we can't resolve this thing in runtime. So you have to add comtime to it. Yeah. So short version, you cannot have types in runtime. There's no like runtime introspection of types. The only thing you can, the only thing is like you can do is switching on like union tags, or having an interface that is based on opaque pointers. But even then, you're kind of assuming that the pointer that you have points to the correct type. So, yeah, short version, there are no runtime types. Runtime types would just be JavaScript-like objects. I mean, sure, you could probably encode the types. It's just that they don't exist in runtime. Just like JavaScript, well, I guess that's not entirely true. Like even, I mean, all languages does have to have some kind of type information. It's just that sometimes it's just embedded in the operations, I guess. Yeah, I mean, in JavaScript you can do type of to get a type. I just mean that the TypeScript types do not exist in JavaScript. It's kind of the same thing there. The TypeScript types do not exist, but then there are some type information that leaks through in the form of like union tags, stuff like that. Hello, MI, what's up? Hello. How's it going? Let's see. Let's provide an allocator here instead. There we go. Now we got rid of that dependency. Cool. Yeah, I'm doing great. I'm working on my game here. Working on the physics engine, collision detection stuff. What are you up to? Are you interested in game development? Oh yeah. Oh now we need to change all these. That's fine. Let's just do these are F32s. Actually, we can just remove these. Hey, now this is old code. You can tell by that alone. to initialize. Oh, I see. We need to fix some stuff in here. So everything that says this type has to have now the argument. This human creature's doing some alien stuff. Oh, so you've been here before then? Sorry, I didn't recognize. Now, this is like the only... I think when you do catch unreachable, you have to have the type. I'm just gonna do a test on that. I'm pretty sure. Yeah. See, now we get incapacity. But if we didn't have catch unreachable here, we would be able to just say this. Actually, I believe even try works. It's just the catch unreachable is not a common pattern, so I think that's why that happened. But whatever. Also, this vector needs to have the element as well. There we go. Yeah. On a scale of 1 to 10, how good is the Zig standard library? Okay. Well, I think it's pretty good actually. But you have to take into consideration that it's constantly evolving at this stage as well. So it's like it's not fully implemented. The documentation is not fully implemented. The direction kind of the standard library is like changing a little bit, or the new versions are breaking stuff and it's like changing things, so it's kind of hard to evaluate based on that. But as far as I can see, like in the direction that they're going, I think it's pretty good. There are some things that is kind of weird, but I do think that they're probably gonna like make things better and make things more consistent, hopefully. But yeah, disregarding that, I'd really like how they especially did the writer interface. And I would say, I mean, I can't really place a number to be honest, but I just think it's good. There's like not many areas I would say is like horrible or something like that. The random stuff was a little bit confusing at first to how to actually get a random thing and how to use it a little bit, but I think that could improve in documentation wise, especially now that they got like the IO stuff in there as well. So now we kind of have two different ways of kind of initializing a quote-unquote default version of the random stuff. So yeah, the IO thing I think is huge. Like that is a huge step in some kind of direction, which I do kind of see the idea there. It's very parallel to how Haskell is doing things. The Haskell has a IO monad, which is taking care of things exactly the same way. It's like it's everything, every side effect that has to do with the file system, networking, non-determinism, that is also happening through the IO monad, basically. So it's kind of the same thing actually. I was really surprised, to be honest, to see that parallel to this language, which is like as far from like as far from functional as you can get, basically, sort of. I mean, you can pass functions though as arguments. You can do that in C as well, but yeah. Anyway. I need to change all the vectors. Boom, boom. Vector that has a... And then I'm gonna do... Not that. And then this is gonna be vector... Wait, why is that matching down there? Why is that matching? I want something that is not. Okay. Oh my god. Okay, whatever. Are there iterators in Zig? Yes. Iterator chaining. And Russ, you could do something like some vector, iterator, map. Okay, so I would say the main way to deal with, like the kind of the canonical Zig way of dealing with those things is not to have a chained operation happening like that. But you can very well, you can very easily write a library to do those kind of things. And I actually did write a, I can show you here. I wrote a generic iterator. Let me show you how it's used. Where is the thing? No, I think it's not this one. It's like... yeah, so here, for example, we return generic iterators. Okay, it's happening in here, really. So here you go. So here's essentially, you can create... basically, I'm creating an iterator from. Now this from is actually generic, so it can take any type. Any type, as you can see here. And then you get a generic iterator element of the type. So what this is essentially, but we do require allocators for it. So it's like you have to kind of, yeah, this is my implementation, so it's like there's probably maybe better implementations, maybe, I don't know. But essentially what this does, since we pass an allocator, we can do some extra stuff there. But you can pass in a slice, which will create an iterator over the slice. And then we create, well, then we call this map with the context. So you can pass like a context to be called in with this function here. So we map with this function to map to a different type here. So we map from this key into dialog option infos, and then we filter with some kind of Boolean function here. And that gives you an iterator, which is a generic iterator. So all of these functions do return the generic iterator type. So you can essentially keep going, basically. You can keep, keep going with this. and do more things. I haven't done a lot of things with it, but you have the basics things. You have map and filter, and then what you do is you grab these, and well, here it's also we're mapping something else, so we return this thing here. And what's crucial also that you can have any type of source. You can have just a slice or an array, or well, maybe not an array. It has to be, I guess, yeah, it has to be like a stable pointer, I guess. But something that lives, like the lifetime is also important. Like you can't just create an array and return that as an iterator. You have to like create the space for it, like a stable pointer for it. But if, as long as you're keeping track of the lifetimes and everything, you get the responses back here. Now this one is, well, here we're kind of checking if we have any responses. This could just be its function on its own. We also have reset, which resets the thing. Responses. I guess you can also say count. However, this is like less efficient because this goes through the whole thing and then resets. So there's no like convenient function for saying. Well, I guess there's this is empty. This does reset first as well. Yeah, I guess makes sense. I mean, could just do that, I guess. So yeah, so it's really convenient because you can map it, you can filter it, you can provide any type of sources. We can have an iterator, another iterator as a source. So yeah, you can absolutely write a library, because I've done it, you know, for these types of things. But there is no like built-in generic iterator. But there are plenty of iterator type structs that kind of follow the same pattern. Like they don't share any type or anything like that, but they do share a pattern, a common pattern, where you call next. There's a function called next which returns a optional value of some kind. And some iterators have reset, some does not, some do not. Like there's tiny bit differences, but the main thing is that you have a next function that returns an optional value. But this library that I wrote is meant to be used like you have one type that you pass around. So yeah, so I'm actually, yeah, and it works really well. So I'm actually kind of happy with that. With that one. All right. Let's see. Did we do everything here? What I'm gonna do is I'm gonna comment this out for now. And I'm gonna run the test example program, and it's gonna fail, and I'm gonna check what the hell is going on. Process terminated. What? Oh, build failed. Yeah. Why though? Wait, what is happening? Was it just some weird one-off error, or what's happening here? I'm gonna delete sig cache, because sig cache is like, it can grow indefinitely. And sometimes it messes up the disk. The virtual disk here gets full and everything breaks. I'm not sure if that's what's happening here. Okay, good, it's not. What the hell is going on? What if I just do build? Because I'm usually building for Windows, but process terminated with single seg v. This almost feels like a compiler bug or something. Also, I would say there's no such thing as like traits in Zig. However, yeah, and you know, kind of extension methods in C# or anything like that. Like, the only way you can type, you know, a plus from or whatever, some like map or whatever, is that if map was actually defined in the original struct type that you had from the start, like that A is the type of. So you cannot like add new functions later to a struct, but you can, you know, do this to just have it at first. And in fact, it's just syntactic sugar, of course. This is syntactic sugar for this. So like that, this is just syntactic sugar for this, and that's a perfectly valid way of doing it as well, which is actually more kind of like how Haskell does it. So even more parallels. I'm gonna find so many parallels to Haskell. Now, what the hell is going on with the compiler here? Do we get the same issue here? I mean, I would assume, since we're using that library, it would be super strange if we didn't get the same error. Yeah. Or, I mean, I haven't looked at it yet, but yeah, there we go. Very strange. What the hell? The only thing we changed was basically the vector. I mean, we could go and see if we can find any more things in here that changes things. Maybe it's like a circular dependency issue. No, I wouldn't think so. Also, this, you can replace this with this. I actually think this is also better. Because then you don't have to, like, if you want to change the signature now, you don't have to change this everywhere. Okay. And then we can also alias like vector E if you want. So now vector E. Yeah. There we go. All right. Is that the only place? No, it's over here as well. so we did change this. Ah, it's not changed over here. Is that really everything? And this is also not changed. Okay, and now we get these. So allocator. Do we have an allocator in here? Yes. Member function expected reorganized. Wait. Oh. You actually did allocate it out. I mean, this is kind of stupid, I guess, because why would we need to ensure here? Instead, we probably want to ensure here and not here. I think it's just because we centralized the thing. But again, if, let's say, instead of ensuring at all, we would say here, we would say like, we could add a branch here to check if this accessor is valid, and if it's not, or even here, we return like, if it's valid, we return a default value, which should be 0. So actually, we could change this. If it's valid, we get an accessor and we return with the accessor. Otherwise, we return the default value, which we just set to 0. That could also, I mean, potentially be, I mean, yeah, now it depends on the, it kind of depends on the type here. And to be honest, we could also, like, default value, we could actually put the default value there instead. And even more a reason now, even now we changed the signature. This default value is not used, so this will be the default value. So depending on which array list you want to use, this default value can change. So there we go. And we're utilizing also here the optional, because I want to change this to return now. I want to change this to an optional accessor. And instead of doing ensure capacity, I'm going to check like if let's see. Basically, element to number of vectors. If this is more than, I mean, we could say if has capacity return if this is more than or equal to we need self list items length or wait. No, that's the capacity, and then we expand to the capacity. Yeah. So I guess the because this doesn't require. Yeah. Okay, we can do this. Has capacity. Smaller than we go to that, then we want to expand to capacity if it's not already done. Like, this is such a quick operation anyway, so we do that, then return the thing. The problem, though, is the undefined stuff. But anyway, if we don't have capacity, we return null. Because when we expand the capacity, we might have stuff that's like undefined. And we are not actually dealing with that. Okay. However, now we don't need the allocator anymore. So this one simply checks, do we have capacity? Then we get an accessor. Otherwise, we return null. Then we need to change these operations to get the accessor like this. If we have an accessor, we get it and we use it. Otherwise, we return that. Yeah, so that's, we need to do that over here as well. If we have this, get it. Okay. Otherwise, return a pointer. Okay, this one is actually different then. This is different. Because now we actually do want to have a pointer to it. Okay. Well, I guess in this case, we do want to ensure the capacity. But now we actually need an allocator here. Unless we change it to be like return optional or something like that, but also now we know that this should exist as well. And this one is null. And actually you are not even used, so we'll get rid of you. Yo, Penguin, what's up? Same thing here. Like, if we want to set something, then we should ensure capacity. We pass this along. Then we get this accessor there, and we can unwrap it. And we also need a navigator. Let's see how much damage this will do here. Right, we need to do this first. So I think what we want to do is I want to do like vector array list is vector array list f32 default value is 0. Okay. And then basically everything here that's called vector array list f32 is going to be called val. There we go. And also we're gonna search for this, everything that is called vector array f32 is gonna be VA. There we go. Now let's see, we have a whole bunch of places we need to fix some stuff. We do have an allocator over here, so we can just use that. I think all of these we need like this. What? Oh, there we go. And what is allocator? Allocator is self. And of course, now you need allocators. Oops. Wait. No, you don't need allocator. You need allocator. Right. So this would be like get p. That's it. Still strange that the compiler would get that weird error that we got before. Okay, we still get errors. Okay, now we get another error here. Attempt to use a null value. Okay, fair enough. So why would that be the case? We ensure the capacity. That should work, unless this is wrong. So wait, so capacity is like if this is 1, we should be able to populate the 0th index. But this should talk about the index, right? I think that's talking about the index. So it really should be like +1 somewhere here. This should be +1. We still get the error. Attempt to use null value. And this should also be +1. The capacity should be +1. But this is elements. No, because this is like, no, yeah, because it needs to be +1 because index 0 +1 is 1, yeah. Still. Wait, this is the wrong way around. If we have capacity, then this would be like this. And this is I'm just trying to figure out the one-off error here, if there is one. So if it's equal to the capacity, this is which, how many vectors do we need to store this capacity? It's already +1, so I think this should be equal. Yeah. Okay. There we go. So, what have we done here? We have changed the array list, or vector array list. So now it can take a parameter, 2 parameters. So one is the type of element inside, now that we need different. And then the other one is the default value if we didn't find the thing in the list. And also we got rid of the allocator here, so that we can easily create this here without an allocator. And some operations changed. So now some operations we need to provide the allocator, so that's good. But now get does not like modify the list unless, no, it simply doesn't. You don't need any side effect things going on, so that is good. Get accessor actually doesn't do a whole lot. So like modifying the list, the only thing that does is set now. So set does need an allocator, which makes sense as well. So yeah, so that's great. Now let's go back to the chord tree and continue with this thing. Okay. Now, how do we deal with this? Instead of doing this weird inline thing, what we're gonna do is we're gonna do calculate result. And this is going to be a void. So calculate result. Essentially, what do we want to do? We have the entity maps. The idea here is that we want to do some kind of calculation. Actually, this is kind of weird because let's say we have like 3,000 entities. It's going to be a lot of maps here, but it's only U2 for each entity though. But essentially we have like 3,000. Oops. 3,000 times 3,000 times 2 bits, I guess. It's not really, yeah. So that is like 9 million. I mean, let's say we have a byte here, so 9 megabytes just for this filter here. If we want to have a map for each entity, which other entities they are eligible, which is not really feasible. So the entity maps would be just 3,000. But then the result would be like 9 million. I mean 9 megabytes, it's not really that much though. I'm like acting like it's a huge amount of data. It's actually not. I mean, it's quite a bit. It has to be stored in the heap, but it's not like, you know, it's not like Google Chrome memory hog levels. And we don't even have this much in this game. So now, how do we populate? We need like populate. Guess we could do that from outside, really. Yeah, doesn't make sense. So essentially populate this from outside. We then calculate the result, which essentially does this for everything. So it's gonna be like for each wait. So entity iterator. Oh, we don't have an iterator. Oh, we can call this, we can call the iterate function, actually. Maybe. Or we just do, where is the thing? The list items. This would give us the entity vector. So this is a vector of U2s. And then this one will be so in order to optimize this, we want to set the capacity here to be list length squared this won't happen. Well, actually this doesn't matter. So we ensure that. Then then we know that we have the capacity, so we can do you expand as well? Yeah, you do expand. So we can essentially just say we can use set a that's the entity number. To wait, the value is wrong. The value should be E. Now, oh, sure. I mean, these are basically only used in here, so we can just move them in here. And then, I mean, essentially these and then also this depends on this, so we can actually just return this. Actually, then we don't need you, we already have. Yeah, we can just, well, God damn it. And I will move you in here. And now we have E there. Okay. Now you're a U2 instead. Okay, so we set this. Well, no, this is stupid. This is stupid. So actually, what we do is we append actually we have capacity, so assume capacity. And then the item that we append is going to be the thing here. Whoops. Okay, and then a map is okay, we need a nested loop, I think, yeah. A map is entity vector. Yeah, that's just entity vector there. Actually, let's just call that the A map. Now, I guess this would be like the B map, except if I equals J, we skip. The problem now is like, how do we map? How do we know? Like, we know that the first items -1 would be for the first entity. So if we had 100 entities, the first 99 would map to... But it's gonna be kind of weird if you're in the middle, let's say index 50. We know that, like, how do we map? It's almost better if we just we actually have a result here. It's just that we say it's... So basically, if I equals J, this is gonna be... It's just the reason I don't like this is because the formatting is not gonna look great here. But this is essentially just gonna be 0. Whoops. Yeah. So if I is J, it's 0. Otherwise, we do this. I mean, I guess we don't really, it doesn't really matter if I is J. Do we really want to have this branch here? It's just gonna take more time, I think. Yeah, whatever. Because now the index will match whatever we do. Like the index of this is always gonna match the index of the other one. So that, yeah. Okay. Yeah, you don't exist anymore. Well, actually, you do exist. It's just valid vector. There we go. Okay, so we didn't really change anything. You know, algorithm-wise. Okay, it would be nice to see, at least today we could get this in and see if we could make this work here. What we need to do is we need to add this to our quad tree and then use it as well as populate it. That's the 3 things. So adding it should be simple here. It's just where's the thing? Here, we just add it over here. It's section filter. All right, there we go. And now we can add an empty one as well. There we go. Now we have an empty filter. Wait, did I remember to prime this here? So we're doing this. We should also like reset. No, the result is, yeah, we need to reset clear it. Retain capacity. There we go. Actually, does that even matter? Yeah, it does matter because we're appending, so we have to reset it. Yeah. So essentially, we're ensuring that we have the capacity. We clear the list, retaining capacity. This essentially just sets the length of the list to 0, but the capacity is still the same. So we still have the allocated space. We just set the length back to 0. And then when we append, it's using the length to understand how much space we've taken up. So if we didn't do this, we would just keep appending to the end of the list, and this would eventually crash because it's assuming capacity as well. Right, so now we have that in the quad tree. Now what we need to do is when we populate, now we could probably optimize this further, but when we populate, we wanna update, we wanna also like prime that intersection filter. So let's see, we basically need to go through each entity map and fix that. Actually, I need to do that from outside. I need to do it from the container actually. We need to do it probably just here actually. So one time every frame. It's not. I don't think we don't need to do it every sub step in the physics simulation. We just need to do it the first time here. And we have this is a quad tree, except now this thinks it's a R tree because I have different implementations at the same time. But ignore that. This is intersection filter, and we don't get completion here, but essentially what we want to do is we want to fill entity maps with information about the entity. So essentially, I think what we're gonna do, we're gonna do we actually have a way to get all the entities? I think we have to do like view rigid body flat. It has to be the same order. I mean, I guess it's gonna keep the order. I think it's gonna have the same order as this here, self view data. Yeah. So this would be get the body. We will then set a for set with accessor from I, which is the index, and then we set basically let's just hard code this in here. So I'm gonna say like if body s is static, we have that, else that, and then we OR that with solid. Now it's like this instead. Looks horrible here. Okay. Yeah, so essentially if we're static, we set this flag. If we're solid, we set this flag. Okay. And that should be it. Oh yeah, I forgot about the allocator as well. So we need to pass the allocator. There we go. We could probably prime this as well to set the capacity, although it will probably only be like the first frame it will be different, so it doesn't really matter. Okay, anyway. So now we've populated the intersection filter with the entity maps. Then I think well, this is just going to be an experiment to see if this actually works at all. So I'm just going to do it from here. Intersection filter, calculate result. We do need an allocator. Okay. It's going to be interesting to see if this actually takes any time as well. Memory function expected 2 arguments, found 3. Oh, I see. This doesn't actually require an allocator. I see. Yes, that is correct. Thank you, compiler. Intersection filter. So actually, we need to ensure the capacity here. So here we need allocator and so on. Ensure capacity. Capacity is going to be data length. I think that is the that should be the only thing we need. Now what's going on here? Comp time only. Comp time int. Should be like, oh, yeah, but it is. Wait, value with comp time only. Oh my god. Does that work? Okay, that works. It needed to have a type. Maybe. Okay. Let's see what's happening here. Mixed scalar vector operands U2 and vector U2. Okay. Oh yeah, because this. Right. So we need to do a splat. Can I just do splat? Will it understand which type it is? No. Actually, you know what? I want to add a convenience function here. Actually, is there a scalar here? No, I don't think so. Scalar. We don't need self. We only need like the scalar. This will return the vector, and it's just gonna be splat s. So now we can say well, I'm gonna say val if val now we can say if val scalar static. Actually, we could probably. So static. I'm gonna do like static check. It's gonna be this part here, and then we'll have solid check. It's gonna be the other part. Oops. There we go. And then this will be static check or solid check more than 0. And I'm gonna do this to make sure nothing weird is going on. There we go. Since we are now working with, oh yeah, and this will be the scalar as well. We are working with vectorization now, so anything can happen basically. Expected U2 found bool. Oh yeah. Oh yeah, so the result list could actually just be a bool. That is true. Wait. I'm just thinking how this works, because in the vector functions, I'm not sure how easy it is to. I mean, I've not looked at it much, but I'm not sure how easy it is to convert like a U2 into a single value, like a single bool. Like usually you, as from what I've seen, you take like two similar vectors or arrays and then you perform an operation. But yeah, they could be, I guess, operations that collapse this into another thing. Probably, maybe. Because this would take each U2, compare it to another U2 here, and then produce like the result would be a vector of the same length, but with booleans now instead of U2s. Okay, well, I guess we could have that. I mean, that's way easier. So we'll just do that. And these can be constants as well. So we'll do like vector static. It's gonna be scalar static. Vector solid is scalar on solid. So this would be static solid. Expected type 2048 bool found. Interesting. Oh, it actually. Wait, what? It. Oh, so the calculated type is a 1024 vector instead of a 248. Is it because it's like collapsing a U2 into a bool? So it would divide it by 2? Do I need to add another thing here? We could do this. We could make the size configurable. So we have the type, element type, the default value, and we can also have the elements. But what I'm thinking we'll do is we'll add like a setting here. So it's gonna be like size options. Which is going to be like a union enum. So either it's like default, and this would depend on that. So if size option is default, well, this could be a switch. Then it's like 248. Otherwise, it's, I guess, custom. And now we can just do that. Default. And you are default, and well, since we have to divide it by 2, I guess we have to do like vector size. It's gonna be that. And then you are also going to be custom vector size over 2. There we go. Okay, so now we are populating this intersection filter in the quad tree thing. We're also calculating the result. We're not really using the result, but we are calculating it. Let's see how much we're lagging now, if we are lagging now. So this will happen like once each frame. Oh. We're crashing. Unreachable code. Okay. Array list. Quad tree 1155. Oh, assume capacity. So this apparently did not have the capacity needed. So here we are ensuring the capacity to be n entities squared. We're retaining the capacity, so we should have the capacity. Here we're appending assuming capacity. How many capacities? I mean, it looks like it's n entities squared. So And actually, we don't even need to mess with this append assume capacity. We can also just say that expand. We can expand the capacity, and we can also just go items I equals this. We don't even need to worry about the thing. This would be like A, and this would be B, and then I is going to be A times entity plus B. Yeah, and we need the ranges here. Okay, now, I mean, it's kind of weird, but I mean, I guess we're gonna get a index out of bounds instead now. But I don't understand how, but yeah, we'll see. Yeah, index out of bounds, index 2, length 2. Ensure capacity. Okay. Ensure total capacity. So this is the B capacity we need. That should make sense because we have like, if we have one entity, this is going to be 1. So we need 1 capacity. That should be the capacity. If we have 2 entities, we're going to need 4 entries. That makes sense. I think. Wait, is it square? Yeah, it is. I mean, it's not exactly squared, but it's close enough. Squared should be more than what we need. Because each entity needs like to be able to intersect with every other entity. So it's like, yeah. Anyway. I think it's like factorial. Anyway. No, it's not factorial. It's like the plus version of factorial, I think. Anyway, ensure capacity. This calls ensure total capacity elements to a number of vectors. Expand to capacity. Right. Wait, I'm thinking about this the wrong way. Right, because this doesn't... This is... Okay. This is the element. Okay, and then we do array list. Wait, let's see if we have it here. No. Elements to number vectors. No, this is actually gonna be. No, we want to set the entire list though. We do want to set the entire thing. Actually, no. This should be only a. Right? Wait, what the fuck? So, result list items. This items is one sheet of what? It's gonna be. I'm kind of losing it here. So this. So essentially, this is a list of vectors that has all the entities. This is a list of vectors that have all the entities. So this index is not the index of the entity itself. It's like the index of one of the vectors in here. And that's what we're also setting here. But still, okay, I see. So this is not the number of entities. This is number of entity vectors. Okay, this makes a little bit more sense. Also, ensure capacity. I'm actually gonna use this one because it's more accurate right now for what I'm trying to do. It's more easy for me to think about in terms of this. So we're ensuring that total capacity, the total number of vectors that we have is going to be this. We expand to that so that we can just set these things without calling any functions or anything like that. We're essentially creating we're essentially allocating a buffer here that we can just use willy-nilly, and we're using every bit of it, and then that is set to that. So now we should be good. So this is the first sheet of this. Yeah. This makes more sense, hopefully. And you need allocator capacity. This last thing is not necessary. Why did you go over there? Catch unreachable. I don't recommend using catch unreachable. It's just that in this project, that's just the way I built this one. And there's too many places to change that now, so I'm not doing that right now. But I would recommend not using catch unreachable and using try instead. Essentially, all the try. Oh, nice. Now it works. Okay, doesn't lag too bad. That's good. Essentially, the catch unreachable thing is like the only place I use it in the projects here is when you can get an out of memory error. So that is that. But yeah, I would recommend using try instead because it's so much easier and it's better integrated into the syntax and language and all that. Okay. Now, let's see if we can try to make this work now. So we are calculating the result. Now let's see if we can use it to our advantage. Where is the thing? We have the thing over thing. container. So here we're populating the intersection filter. We are calculating the results. And now we can populate page by page. And we now have our intersection filter in self. So we can essentially access it from anywhere. Populate is not the place we want to go. It's gonna be report, search and report intersections. So now we basically want to have, we're gonna go in here, we go through all the entities, intersection bottom up. I think there are like multiple places where we need to check this here. This kind of operation is happening at a couple of places, so we need, basically what we want to do is we want to add a thing here, and we want to say intersection filter something something something. So basically if result, this is gonna be like get, and we have the thing, so we don't need to worry about not having the thing. We need the index of the entry we wanna check from. I don't think we even have that. That is too bad. Actually, these are orphaned, so do we even care about these? Let's not worry about the orphaned ones actually. Let's do some other things instead. Search. No. Bottom up. Page bottom up, quadrants. I think this is the one we want to. Entries in page is probably the endpoint, the terminator, I think. Brute force. Oh yeah. I messed around with having like a sweep algorithm in here as well. The problem with that is that the sweep is like made for comparing. You get like groups of things. I don't know. Anyway, intersecting entry. Right. And this is the index, so that's important. We need the index. So here we're gonna say if get from entry, so that's the result, the filter results there. So now we have like, wait, that's not correct. Well, okay. I think, okay, so, okay, I think I set this up a little bit weird. So essentially we need to calculate what index do we need to access. And it's gonna be the entry. So this is gonna be the filter page, essentially gonna be entry times how many entities we have. So no, yes, so that's gonna be entry values. That is how many entities we have. That's the page, and then the filter index is going to be filter page plus what? We don't actually have this. We don't have the information. We need the index of the thing that we are trying to compare against as well. Wait. I just thought of something. Like, what if we just scrap quad tree and just do like a vectorized brute force instead? Like, we store all the points. And like compare them. No. Anyway. Intersecting entries in page. Entries, brute force. But we have like one ABB that we're looking for. The problem is that sometimes you want to call this function without having an index to compare to. Like, we essentially have two different use cases for finding intersections. One is the general finding collisions that is going to be used in the physics simulation, and that's what we're doing now and trying to optimize. The other case is when we're trying to just say, you can give an arbitrary rectangle or shape and say, hey, what entities are within this shape? That is a different thing, because then you don't really, it's not tied to another entity that we can have cached information about. So that will be essentially a different algorithm, actually. And see here, we're using like an optional index. The problem is I want to pass this along like everywhere, not just here. Also, you are called here as well. See here, we're just applying an ABB because we don't have an index that we're trying to compare against. This is used from outside to just find things that are within a rectangle. This one though, so it's like we're sharing some of these functions. This one always has an index. Yeah, so we could just pass that further down. This function, it seems like it's the only one that doesn't actually doesn't have an index. So, I mean, let's just add it. And you as well. So there we go. Now we have the index. And also over here. Okay, so now we have the index. We need to figure stuff out as well. But this is essentially just gonna be plus index. But this is also only if we have index. So then we're gonna have the index I. Now this index, so entry is the one we're comparing against. Index is like the source entry we're comparing with. Very well explained here, but let's see. So this will be the filter index, and this will be I. So it's like if we have an index, we can utilize the intersection filter cache to see if this should even be considered in the result. So if this is true, then we should consider it. But if it's false, no, I think it's the other way around. If this is true, we need to not consider this. So we simply return. I'm pretty sure. Because we go over here, this calculation is like saying either both are static or one of them is not solid. If this is true, it means the result will mean that we should skip that. Yeah. And oh, wait. Wait, which yeah, we're using 0%. Okay, now we get this error again. Wait, didn't we fix this? Didn't I fix this? I'm pretty sure I fixed this. Oh, maybe it wasn't fixed here. Self list items. Yeah. Oh yeah, because this just gets the thing. There we go. Okay. Yeah, we needed to. So the new version in Zig doesn't allow indexing into vectors because there's some kind of weird bug, I think. So what you need to do is you need to like basically cast it to an array first, and then you can access it. So yeah, essentially this will be turned into this here. Okay. Right. So now I think that we have added this little check here, which should skip those entities that don't even need to be checked in the first place. Okay. I was like, is this really gonna work the first time? Of course not. Index out of bounds, vector array list 116, get a from quad tree 836. Okay. There's something wrong here then. Index 11. Hang on, no. This is I. This is entry. But does that even matter? Like, we should be able to get both of those. I'm pretty sure. Yeah, we still get index out of bounds. Man, I really would like to get this working and just try to see if it works. And we've given it our best to see if this actually does anything at all. But okay, I want to do this like if index around index 16. Okay, maybe we'll change this to not be a vector array list, and instead it's just going to be an array list of vectors. So essentially, well, vector size over 2 and the element is a bool. Okay, this is more what I had in mind. It's like each entity will map to a vector of results. And so now I'm gonna do this. This will be like items. I also need to change this a little bit. So ensure total capacity. So this will now be vector, no, yeah, vector size no wait, yeah, vector size times vectors, right? So it's like if we have one vector, it's going to be up to this size. If we have two vectors, it's going to be up to this size. So like one vector will have capacity for 2048 entities. And then this capacity, since these are vectors themselves, we just need to store the same number of vectors. Essentially, well, we need to store one for each entity, which would be the thing here. So there we go. And then we expand to capacity. Whoops. And then that should be that. Now the problem here is now the length of this result is not necessarily the same, but we are actually never really looking at the result in that way. So I think it's better if we just do this. This should probably be fine. Now we'll go here. I'll copy this as well, and we'll say, so now these are a bunch of vectors, and the kind of page we want to look at is going to be I, or the index, and then we have a vector, which I just remember we can't access like this, but essentially we want to look at the entry for that thing. And we don't even need these. But now we're gonna get an error here. So we need to do the same thing as we did over here. We need to get these things here. This will be type of texture filter items I. Okay, and that gives us the vector we need to look at, and then this is the same thing we cast. Now section filter result items I. There we go. Now we have our array, and then we simply check if that is true, then we return. Okay, will this work now? It does work. I don't see any significant increase in FPS, and also I don't collide with some of these, like this one. We just go straight through for some reason. Those do work. So it's only that one that didn't work. No, it has to be like a weird coincidence. Like if one doesn't work, there's probably others that doesn't work as well. I'm gonna go down to these things down here. Okay, well, that's not really promising. But I mean, I guess the potential it could have saved for the game is essentially like maybe like 1 millisecond per frame. So it's not even gonna. Yeah, we'll see. We'll see. It probably won't really save much of anything, but let's try. And this will be the last thing I'm gonna do today, so I'm not sure if I'm gonna keep on trying to optimize this stuff right now, because I would like to also like work on more like the content of the game instead of working on the engine. But yeah, we'll see. We'll go over here and we'll see how much like what if at all this has changed anything. We do consistently get like 100 FPS here, so that's good. Let's see, is it this part or is it the next one? No, it's the next one. I think I want to add more like variation to this part. Like maybe some rocky terrain somewhere. Just a tiny bit to give some texture to it. Alright, here we go. Moment of truth. I mean, no, there's basically no difference. And not even when I try to pick this up. I'm not sure if we actually gained anything or if it's like, yeah, it just stayed the same basically. It's gonna be interesting to see maybe with Tracy if there's any difference at all. But yeah, I think we basically, we also, you know, we traded. It's not like we're getting anything for free. We also we traded some calculations for others. So yeah, I don't know. Maybe we'll leave this alone for a little bit and come back to this later. Try a few different other things at some other point. I do want to try to get to do more content, as I said, like I think what I want to do is I want to like go through the first area and basically kind of try to expand it a little bit and add more variation, more space. But yeah, that's gonna be for next time. So yeah, thank you very much for joining me and hope you have a nice day, and I'll see you later. Bye bye.